There are several ways to grow bismuth nanowires. I would divide them into two main approaches. One is to use templates. These templates are usually, you can get commercial templates, usually either alumina membranes or polycarbonate membranes, and you simply use the pores inside the membranes to grow the nanowires in them. This can be done by electrochemical ways, also by insertion of bismuth melt with high pressure. But I would say that the electrochemical methods are the main methods used here. The main advantages of this approach is it is relatively very easy. Okay, you can simply get a commercial template and grow the bismuth nanowires, eventually dissolve the template and get the nanowires. If you want to create the template by yourself, this can be very challenging. And since commercial membranes contain pores only with diameter higher than a few tens of nanometers, if you want to go down to very low diameters, you will have to try to grow the membranes by yourself. And so the other approach, I called it wet chemistry growth. Here you use chemical precursors to grow the nanowires inside a solution. Here you also have a template. It is actually a soft template. The surfactant molecules which cover the nanowires as they grow. Okay, you reduce the bismuth ions, and along the growth, the surfactants, they have special affinity to some lattice directions, and so they direct the growth of the nanowire in a certain direction. This kind of approach also, it requires a very high know-how, very high level know-how. It is much more difficult to grow bismuth nanowires compared to gold nanowires. And so I would say the main disadvantage here is that the nanowires are grown in a spaghetti-like structure. So if you want separate nanowires, it is more difficult to get them in this approach. Overall, the bottom line is that growing of very thin bismuth nanowires, let's say below around 15 nanometers, is still a very big challenge. Allegedly, you can think, why not trying the top-down approach? It is applied on other materials. This approach means, let's take a nanowire with relatively high diameter, which can be easily done, and then try to etch it and lower its dimension to the desirable dimension. But this approach is very problematic in the case of bismuth, because the bismuth has a native oxide, which is its chemical resistance is much higher when you compare it to bismuth. And actually, today in the literature, there is no report on any material which can etch bismuth oxide faster than bismuth. So this approach is very difficult when trying to apply it on bismuth.